Dear students, based on the three axioms, completeness, transitivity, and non-satiation, indifference sets are a set of curves. Indifference sets are a set of curves where each indifference curve is the locus of points. Locus of points means commodity bundles that yield the same level of utility. So an indifference set is nothing but set of curves where each indifference curve is a locus of points, commodity bundles that yield the same level of utility. That is, using these axioms, we can define indifference set as a set of curves where each point on the curve represents same level of utility. Each point on an indifference curve is a commodity bundle. So every point along an indifference curve represents a different combination of two commodities. Every point is a different combination of two commodities, and each point is, or each combination of commodities is equally satisfactory to the household, in the sense that each combination yields the same level of utility. Each combination yields the same level of utility, so that these bundles are represented by an indifference space. Now consider this graph where we consider two commodities, x and y, quantities of x and y, and consider indifference curves represented by levels of utility u1, u2, u3, etc. And consider the points x, z, w. Consider the commodity bundles, combinations of x and y represented by points such as h, z, w, etc. We have given three indifference curves represented as u1, u2, etc., u3, and the bundles h and z are on the same indifference curve. So bundles h and z representing different combinations of x and y gives same level of utility. On the other hand, w is on a higher indifference curve. So w represents a higher level of satisfaction. Now, according to the non-satiation axiom, increasing either x or y, or both x and y, increases the utility, the satisfaction received by the consumer. And as you move from indifference curve u1 to u2 to u3, and a movement involves an increase in either x or y or both, the utility received by the consumer increases. And we will say that he moves towards what is known as global bliss. The non-satiation assumption states that the aim of as the consumer moves towards the right, that is, move from one indifference curve to another indifference curve, the level of utility increases. And his aim is to reach the global bliss. But the problem is, the consumer will never reach global bliss. Global bliss is a point that I will explain in detail later. So he will not reach global bliss. So there will be an infinite number of indifference curves in the utility space. There will be an infinite number of indifference curves, and between any two indifference curves, say u1 and u2, there will be an infinite number of indifference curves. So in the utility space, there will be an infinite number of indifference curves. That is a point that should be remembered. Now, an important property of indifference curves is that two indifference curves never intersect. An important property of indifference curves is that two indifference curves showing distinct levels of utility cannot intersect. You consider this case. This is one indifference curve. This is another indifference curve, y, x. Two indifference curves. This indifference curve represents level of utility u1, this u2. They cross at point E. Point E. Suppose also that there is a point here B. This is a point C. 2 points here D and C, and this is A. Now, as what you can see, A is preferred to B. A is preferred to B because A contains more of both. Then C is preferred to D. C is preferred to D. Also that B is indifferent to C. C is preferred to D, A is preferred to B, and B and C are on the same indifference curve, so B is indifferent to C. Now, consider this. A is preferred to B, C is preferred to D, B is indifferent to D. Then it follows that A is preferred to D. B is indifferent to C, so naturally A is preferred to C. We will get the conclusion. But A and D are on the same indifference curve. A and B are on the same indifference curve, so A cannot be preferred to D. But from the transitivity axiom, A is preferred to D. But as A and D are on the same indifference curve, A is indifferent to D. That means if two indifference curves intersect, it violates the axiom of transitivity. It violates the axiom of transitivity. So an important property of indifference curves is two indifference curves cannot intersect. If they intersect, they violate the axiom of transitivity. Now let us consider how we draw an indifference curve. Suppose that an indifference curve is represented by u0 is equal to x into y. Suppose also that u0 is 12. Combinations of x and y which yield a level of utility equal to 12. Maybe 1 and 12, 12, 2 and 6, 12, 3 and 4, 12, 4 and 3, 12, 5 and then 6 and 2, 12, like this. If you plot this on a xy space, you will get an indifference curve representing a level of utility 12. So, because this is a utility function u0 representing an indifference curve where utility is equal to 12. Now, consider this indifference curve again. Consider this indifference curve again. As you can see, the slope of the indifference curve is negative. The slope of the indifference curve is negative. It means that the individual is forced to give up some y, he must be compensated by an additional unit of x to remain on the same indifference curve. The negative slope means if the consumer is forced to give up some unit of y, he must be compensated by some unit of x so that he will remain indifferent between x and y, or he will receive the same level of utility. This is because of the assumption of non-satiation. More is preferred to less. If additional units will give a positive utility, when the quantity of y decreases, there will be some loss of utility, and this must be compensated by an increase in x, that is gain in utility. Now, a measure of this substitution of y for x is known as marginal rate of substitution. Marginal rate of substitution. And marginal rate of substitution is the negative of the slope of the indifference curve. The slope of the indifference curve is negative, as you can see, as indifference curve is negatively sloped. And we take the negative of the slope of the indifference curve, and the negative of the slope is what is known as the marginal rate of substitution. So this is dy and this is dx. At a particular point, the slope at say point A is dy by dx, and dy by dx is a negative number. So slope is dy by dx, where u is a constant. U is equal to, or I can write it as uxy is k. That is utility represented by a particular indifference curve. Uxy is equal to a constant, and mrsxy is equal to negative of dy by dx. where uxy is a constant k. Uxy is a constant k. So MRS xy is the negative of the slope, and I define MRS xy as the number of units of y substituted for getting one more unit of x. In different textbooks, you will see different interpretations to MRS, different ways in which MRS is defined for a movement from left to right, right to left, etc. So for consistency, I always write MRS xy. If y is on the y-axis, x is on the x-axis, and I define MRS xy as the number of units of y that should be substituted for getting one more unit of x and remain on the same indifference curve. And as we know, this dy by dx is negative. So MRS xy is a positive number. MRS xy is a positive number. Or we will say that MRS xy is the negative of the slope. Also, MRS as a measure of the willingness of the consumer to substitute y for x. MRS as a measure of the willingness of the consumer to substitute y for x. It is related to the marginal utilities of the commodities. That is, we can show that MRS xy is equal to MUX by MUY. MRS xy is MUX by MUY. That is, MRS xy is the ratio between marginal utility of x and marginal utility of y. And this interpretation is useful later when we define the equilibrium of the consumer. Now we can derive this result very easily. Let the utility function is u is a function of x1, x2, etc., xk. Now, this relationship is derived by taking the total differential of the utility function, that is du, is equal to dou u by dou x1 into dx1 plus dou u by dou x2 into dx2 plus etc. dou u by dou xk into dxk, and it is equal to 0. Along an indifference curve, change in utility is 0. And since dou u by dou x1 is mu of x1 into dx1 plus mu of x2 into dx2 plus mu of xk into dxk is equal to 0. Because dou u by dou x1 is mu of x1 into dx1 plus mu of into dx2 plus etc. is equal to 0. If we consider only two commodities, then u is equal to xy. U is a function of x and y, then du is equal to mux into dx plus muy into dy. Mux into dx plus muy into dy, and it is equal to 0. That will give you mux into dx is equal to minus of muy into dy. Now what is dy by dx? Dy by dx is negative of mux by muy. What is dy by dx? Is negative of mux by muy. That is the slope. And if I define negative of dy by dx is equal to mux by muy. Mux by muy. So this is how MRSXY is related to the ratio of marginal utilities of commodities. Marginal utilities of commodities. And this is a point which we will use when we define the equilibrium of the consumer. Now, let us consider a concrete example to explain what is MRSXY. Suppose that U is given as x1 raised to half, x2 raised to half, x, y, I simply take it as x1, x2. Now, what is mu1 is equal to 1 by 2 x1 raised to minus half, x2 raised to half. This is equal to 1 by 2 x1 raised to minus 1 into x1 raised to half, x2 raised to half. This is equal to 1 by 2 x1 raised to minus 1 into u. Similarly, mu2 can be written as 1 by 2 x2 raised to minus 1 into u. If u is given as x1 raised to half, x2 raised to half, then it follows that MRS x1 x2 is equal to MRS x1 x2 is equal to mu1 by mu2 is equal to what is mu2 MRS mu1 by mu2 is equal to x2 by MRS x2 by x1. MRS xy is equal to mu1 by, that is mu1 by mu2, that is x2 by x1. Because so x1 by x2, mu1 by mu2, and x2 and x1 are positive quantities. So MRS x1 x2 is also a positive quantity. 1 by, so simply mu1 by mu2, 1 by 2 x1 raised to minus 1. So it u and u will be cancelled. 1 by 2 cancelled. This will goes to the numerator, this to the denominator, x2 by x1. As an example to MRS. So if the utility function is given like this, MRS is a positive number x2 by x1.